Welcome and thank you for joining me, Miss Trot, once again for Math and Science for Young Children. In each of our sessions, we will be reviewing math, science, and early childhood topics. Our goals for this session are to understand how gender bias impacts children's attitudes towards science and math, identify shape concepts that are most appropriate to focus on for early childhood, and apply science, engineering, and math skills into building structures. Make sure you download the note sheet to go along with this video and stick around as we learn more about math and science for young children. Gender roles can come from biases seen in media, families, or peers. You can see society's messages about gender roles in toys and in clothing. Even traditionally gender-neutral toys, such as blocks, now come in boys and girl versions. Sometimes stores even have designated aisles for boys and girls, which send the message that boys do not cuddle and girls do not build. The hidden messages that girls receive about STEM shape their self-concepts, confidence, and interests in those subject areas. So as a teacher, we need to decrease gender stereotyping by tuning into our own bias, being aware of inadvertently reinforcing gender stereotypes, observing the way children's choices seem influenced by gender, encourage boys and girls to do the same activities, use gender-neutral labels such as police officer, mail carrier, and firefighter, and expose children to models or people in non-traditional gender roles. These will all aid in decreasing the gender stereotypes. Our math focus for this session is shapes. The shape is a form of an object, and in mathematical concepts, we focus on two-dimensional and three-dimensional shapes. Shapes can be defined by particular rules, such as number of sides, length of sides, size of angles, and number of shape faces if you're talking about a three-dimensional shape. A classic mistake that early childhood educators make when working with shapes is that they limit the learning objective to simply recognizing and naming the shapes. And they also present only one typical, stereotypical version of the shape. For example, if a student is only exposed to a triangle with a horizontal base, they may not realize that there are other types of triangles. Knowing the names of the shape is not the same as understanding the rules that govern shapes. We want to go beyond the superficial shape label or name and recognize the defining attributes of the shape. Some key practices that can help children more fully build understandings about shape could include providing a diversity of shape examples beyond the traditional stereotypical version, keep the focus on creative exploration of shapes, scaffolding to help children make their own discoveries, engage children in rich discussions about shapes and their attributes, and help them become more precise in their definitions, make connections to real-world use of shapes and why some things are made in one shape for a particular purpose. We have three big ideas when it comes to shapes. Number one, shapes can be defined and classified by their attributes. As children sort and classify shapes, they become aware about rules of shapes. These distinctions are not immediately obvious to children. For this reason, it is important for teachers to be intentional and to design activities that show them that shapes can be defined and classified into those attributes. Number two, the flat faces of solids, a three-dimensional shape, are two-dimensional shapes. As they explore three-dimensional solids, children will discover that the faces or sides of these solids look like circles, rectangles, triangles, and other common two-dimensional shapes. And number three, shapes can be combined and separated to make new shapes. This is also called composed and decomposed. Opportunities to combine, rotate, and compare shapes will help children develop understanding of part-whole relationships within and among shapes, as when two identical right triangles can be combined to make a rectangle. This is the idea that there are shapes within shapes. Our science focus is the engineering concept with building. Block play and other building and constructing activities promote development in math, science, engineering, language, critical thinking, social emotional, creativity, art, and social studies. Building with blocks and other materials develop a wide range of early learning abilities in STEM. When children have experiences building with many different kinds of materials, they begin to notice the attributes such as size, shape, texture, and weight, and how they affect the design and stability of their construction. A structure is a form that keeps its shape. Structures may be made of one or more parts that can be arranged and connected together in a special way to provide support and stability. Our activity this week is going to be building a structure with a group. You're going to have time to explore and build with different materials, and this is going to be a very open-ended exploration. While you're building, you will be using trial and error, problem solving, creativity, and collaboration. I also want you to notice the math, science, and engineering aspects of what you're doing. You will see yourselves using rich language and vocabulary, and notice your spatial reasoning and problem solving skills and what theories you are using to formulate your ideas and the testing of them. After you complete your structure building activities, I want you to be able to ask yourselves these questions and have answers to what goal did you have in mind while building with the materials at this station? What thoughts do you have about using these materials with children? And what science, engineering, and math thinking skills might children use while exploring these materials? That wraps us up for this session. Be sure to go online and check for all of the other materials and activities posted to go along with this topic. If you have any questions, please reach out to me or your instructor. We are here to help. Have a great time learning, and we'll see you next time.